For this example, when I try to first see if I can use the limit laws in direct substitution, I can see that I cannot. If you notice, if I plug in 0 to each of these individual functions, I get 0 in the denominator. And I can only use the limit laws if the individual limits exist for each of the separate terms or the separate functions. So if I think of this as my f function and this is my g, neither one of them exist at x is equal to 0 as it is. So one trick that we can use, if we have two separate fractions like this, we can try to combine fractions. So I'm going to rewrite the expression 1 over x plus 5 over x times x minus 5 by combining fractions and see if I can simplify it that way. So in order to add two fractions, we need a common denominator. My common denominator is going to be x times x minus 5. So the fraction on the left needs to be multiplied by x minus 5 on the top and the bottom. Now, the fraction on the right already has the x minus 5 in the denominator and already has the x. So I don't have to do anything with that second fraction. I already have that common denominator set up for that second fraction. So now when I combine these two fractions, because they both have a common denominator now, I have x minus 5 plus 5 all over the common denominator, x times x minus 5. Now, the minus 5 and the plus 5 in the numerator adds to 0, and I'm left with just x over, and then in the denominator, I have x times x minus 5. Now, I can get rid of the common factor, but that divides out to be 1, so that whole big mass simplifies to be 1 over x minus 5. So now let's see, now that we have it simplified and rearranged a bit, if we can use direct substitution now. So if I take the limit as x goes to 0 of this new simplified version, that gives me 1 over x minus 5. So I take the limit as x approaches 0 of 1 over x minus 5. And then when I substitute 0 in there, I get negative 1/5. So that will be our limit.